We have a water tank built in the shape of a circular cone with a height of 9 meters and a radius of 6 meters at the top. So let's see if we can get an idea for what that looks like. We have a cone, and at the top, if it were completely full, it would have a radius of 6 and a total height of 9. Right, you guys? Right. Okay. And we have water being pumped into the tank at a rate of 1.8 cubic meters per minute. And we want to find the rate at which the water level is rising when the water is 3 meters deep. That's all we know. So we're going to pick apart what we're given, what we want to find, and what equation will relate these quantities. So first off, just sort of start looking at the numbers and see if you can figure out what they stand for. We know that this is a rate, right? Mm-hmm. Okay, but what's at the rate of?
Volume change.
How do you know it's volume?
Because it's cubic.
Because it's cubic. So it doesn't explicitly say that, but because it's cubic, we know the quantity of water is the volume of the water.
And it's positive.
Okay,
because it's being pumped
and
in.
it's positive because it's going to be pumped in. So we know we're dealing with a volume equation of a right circular cone. And we know that that equation, because we just looked it up in the back of our textbook, is V equals 1/3 pi r squared h. And we actually talked a minute ago about being wary of that equation because it would involve if we took the derivative right now, we would have to do the product rule. But there is a neat trick for cones that you can always use, and we'll talk about it as we kind of go. What are we given? We are given dV/dt, right, you guys?
Yes.
So we have dV/dt, and we know it's positive 1.8 cubic meters per minute. Okay? We are asked to find the rate the water level is rising. So is that h or is that the radius?
H.
That's h. So I'm being asked to find dH dt when what?
H is 3 meters.
H is 3. So do y'all notice that the radius isn't mentioned at all other than just
What we know.
we know the dimensions of the tank, basically. That's the only reason we are given any information on the radius. So basically, we don't care about the radius. That's not involved in what we're trying to find, and we're not given any information on it, really. Do y'all understand that? Okay. The reason they tell you the top dimensions is this. The radius to height ratio will be the same at every moment in time. So that's true for any cone situation. The radius to height will always be a set ratio. So if you know one ratio, you know them all. So basically what we can always do with cones is we can say the radius to the height equals, and in this case it equals 6 to 9, right? Okay. So we know that 9r has to equal 6h. And which one do I not care about? I don't care about the radius, right? I'm not being asked to find anything about the radius. I'm being asked to find about the height, right? Okay, so what we're going to do is solve it for r. And if we solve it for r, we get 2/3 h, right? Okay, this is going to be always true, no matter what h and r are for the problem. At any moment in time, the radius is always going to be 2/3 of the height. You can avoid the product rule if you substitute what the radius is before you take the derivative. So you just rewrite the radius in terms of the height, plug it in and clean it up, and you'll actually only have one variable over there on the right side, and you won't have to do the product rule. Now you could do the product rule. You could, and it just takes a lot longer because you also have to, at that point, figure out what dr dt is. So, it's just kind of busy. It's much easier if you go ahead and make this substitution anytime you work with a cone. So we're going to come over here. We're going to substitute our radius for 2/3 of our height instead. So we're going to clean it up, and we get 1/3 pi times, let's just write it out, 1/3 pi times 4/9 times the height squared times the height. So that will all clean up to what? 4/27? Did I do that right? Yeah, I think so. Let's clean it up. So 1/3 times 4/9 is 4/27 times pi times the height cubed. That's a much easier equation to take the derivative of and to substitute into later. So we're gonna pause right here and see if you have any questions. If we continue here, we take the derivative, we have dv dt is equal to 3 times 4/27, which is just 4/9, pi h squared dh dt. And all you have to do is substitute in everything except dh dt and solve it from there. That's what we're hoping to find. So we'll plug in our dv dt. So we have 1.8. And I'm going to drop the units because to me it's just kind of stressful to track them. So I'm going to say 1.8 equals 4/9 pi times the height squared. So that would just be what? 3 squared would be 9 times dh dt. So it looks like we have 1.8 equals 4 pi times dh dt. Okay. So 1.8 divided by 4 pi seems to be my answer.
Do you want the decimal or the fraction?
Hang on, we're going to do both. First, I want to know what my units are. Height should be measured in meters, right? So its rate should be meters per minute, okay? So we're going to say meters per minute, and you can look and see, you know, what will your height be measured in, what is our time measured in, and that's what you put on for your units. Okay, now, I wouldn't want you to leave it like that. I want you at least to go take the 1.8 and divide it by 4. So do that for me first. Tell me what 1.8 divided by 4 is, but leave the pi.
9 over 20 pi.
9 over what?
20 pi.
9 over 20 pi meters per minute. That is an acceptable answer. So if you want to give an exact answer, you could give that one. If you wanted to go all the way to an actual decimal, you would have to use alpha y equals and take the 9 and divide it by 20 pi together. So do that as well, so that we also have a decimal answer to 3 decimal places. 9 over 20 pi.
0.143.
Did you guys get 0.143 meters per minute? All right, and that's pretty much how you're going to work cone problems no matter what. You're going to have to understand that height to radius ratio and making that substitution that will allow you to not do the product rule.